Welcome everybody to lesson number 3, 2D and 3D applications. So these are basically going to be word problems, but nothing that we can't handle. We're going to dive right into these. Alright, first of all we have a problem that says you and two roommates decide to split the living room floor space equally. How much area will you each get? Well, let's think about it. If you and two roommates are in a room, that means there's 3 of you. And you want to split something equally, which means you have to divide by 3. What are we dividing? The floor space. The floor space would be area of the floor. So we've got to find the area of this floor and then divide that by 3. And we'll get how much space we each get. So here's what I'm going to do. I'm going to cut this piece right here, because now I can find 2 individual areas, right? We've got right here 12 by 4, which is let's see, 48, and then here we've got 8 by 21, which is 168. And if we want the total area, we have to add those. So 48 plus 168, that's 216. That's the total floor space of this whole room. So now if we want to divide it up evenly, we have to divide this by all 3 people. So let's see, that would be 72. So each person will get 72 square feet. Okay? Not a crazy problem. We thought about it. We thought about what were they asking? How do we get there? Okay? All these problems are going to be the same. Take a second, pause the video, really think about the problem, give it a try before you resume. Alright, let's see how you did. It says, except for this circular bowl, this box of cereal is red. Find the area of the red to the nearest hundredth. Alright, so here's the bowl in the center. They say we have a length of 10 and a width of 18. So that would be the area of the cereal box. So that's 180 units of some sort. But the problem is that we don't want everything. We don't want this giant white bowl in the center. So what are we going to have to do is we're going to have to get rid of it. And how do we get rid of it? We use subtraction. So first I've got to find this area and then I have to subtract it. Alright, so area of this circle. Well, this length from here to here is 10, which means the length from here to here is 10. So from center to the edge, in other words radius, should be 5. Area is pi times radius squared, which is 25 pi. So we got to subtract 180 minus 78.54. That gives us 101.46 inches square. What we just found was how much red is on this particular cereal box cover. Now, why would that matter? Not just for fun while you're eating your cereal. Maybe you're designing a new box and you need to know how much ink to put on that box, right? Ordering supplies, you have to know how much ink to use for that particular product. There's other things that we could talk about too. I mean, maybe you're talking about advertising too much red that scare people away. Who knows? Okay, different type of application problem here. Now we're looking at what looks like three-dimensional figures in volume. Okay, they're asking which pool will hold more water and by how much. Okay, we're going to round to the nearest hundredth. I'm assuming that they're talking about feet here. Okay. So what we're going to want to do is find the volume of each of these things and then compare them. So this looks like a cylinder that's been cut in half the long way. So if I find the volume of half of a cylinder, which would be pi, times a radius. Let's see, they show us a radius here of 6 squared times a height here, that would be 18. Let's see, half of 18 is 9 times 36 times pi, and if we type all those into our calculator, okay, that's feet cubed. So this is how much water can fill this thing up. Kind of a cool looking swimming pool. Okay, the next one is this rectangular swimming pool that we're all used to. Big square ones. Okay, the volume here would be length, which is 8, times width, which is 18, and height, which is 7. Now, you think about it. This thing, the radius here is 6. So that means at the deepest, it's only 6 feet deep. And it's 18 feet long, 12 feet wide. This thing, we can see it's 8 wide, which is pretty close to as wide. It's 18 long, so the same length, and it's deeper by a foot. So this one, I don't know, this sounds like it could be a much bigger swimming pool, but I'm not sure. So let's see what they give us. 8 times 18 times 7 is 1008. So this one happens to be longer. We'll say the half cylinder. Now the other thing is by how much? Well, 1017.8. Oops. 88 minus 1008.00. That would be 9.88 cubic feet. Okay. Again, nothing crazy going on. We figured out the two areas or volumes and we compared which one's bigger. And then they said by how much? Well, if we get rid of the same amount from both, what are we left over with? Okay, that's just a quick subtraction. Not doing anything groundbreaking. Okay, you have one problem to try on your own. How many will fit into another? So again, how many pieces will fit inside equally? Think about the operations that you need here. Pause the video and resume when you're ready to check. Alright, hopefully you thought right away to find the volume of both the small and the large. Right? Because we want to know how much space is here, how much space is here, and how many of these things we can put into that space. So we'll find the volume of the small one first. Length times width times height gives us 30 cubic units. We'll find the volume of the large. 21 by 8 by 15, which gives us 2,520. Now imagine, right, this is 3 long, so I could break this up so many times and fit so many of these boxes, right? And this is so tall, right? So I can fit so many of these boxes tall, and it's so wide. How many can I fit, right? So that's what we're trying to figure out. How many of these boxes can I fit inside of here? So if this is the volume of the whole thing, and I have the volume of one of these little ones, I can take and divide this whole thing, and it'll tell me how many will fit into here. That tells us 84 will fit. Okay, so they're thinking problems. You use all the information that we've been using throughout the year to kind of use them to solve smaller, minor problems in which to help you solve these much bigger problems. That's what application is all about, applying. So, short lesson. That's it for that particular one. We've got one more to go in this unit. See you there.